All right. So in our last lesson, we talked about what to do when we were dividing a polynomial by a monomial. Okay. So if we remember correctly, to divide a polynomial by a monomial, if we had something like, so this is just going to be a little bit of a refresher. If we had, let me get one we haven't done here. Something like 8a squared plus 20a over 4a. Or, sorry, not over. Divided by. Over is the next step. So when we're dividing a polynomial by a monomial, it's as simple as just taking our polynomial, the numerator, putting it over the 4a, over the denominator, or over the thing that we're dividing by. So this becomes a division problem. So we have 8a squared plus 20a over 4a. And then we just take each of my terms and divide it by whatever the denominator is. So in turn, this actually becomes 8a squared over 4a plus 20a over 4a, and then we just simplify each fraction. So the 8a squared over 4a, that becomes 2a, and then the 20a over 4a, that becomes 5. So we would end up with something like that, 2a plus 5. Now, the difference between dividing a polynomial by a monomial and dividing a polynomial by a polynomial is that once we have multiple terms in the denominator, we can't do the same thing we were just doing. So when I have a problem like h squared plus 9h plus 18 divided by h plus 6. Here, we are not dividing by a monomial anymore. This is a monomial, a single term. No pluses, no minuses. This is a binomial, two terms, polynomial. So if we have a polynomial divided by a polynomial, okay, the first thing that, well, there's actually two different ways that we can do this. The first way is, again, doing exactly what we did here, making it a fraction and then working with it like we did our rational expressions. So I can take this and rewrite this as h squared plus 9h plus 18 over h plus 6. Now, I don't do like I did here and take each term and divide it by the denominator. Here, if we remember back, I think it was section 3, or 2 maybe, what we have to do with this top, because this is a trinomial, we need to factor it. And we're going to factor this out, and we're going to look to see if we have any common factors on top and bottom. So we're going to take this top one, we're going to factor it, so we're looking for two numbers that multiply to get 18 and add to get 9. All right, so if we look at that, two numbers that multiply to get 18, you're going to have 1 and 18. You're going to have 2 and 9. You're going to have 3 and 6. And I think that that's it. Yeah, that's it. So you're then going to look for which ones will add up to be 9. These add up to be 19. That's 11. And then there's our 9. So these are the two we're working with. So the top one will factor to be h plus 3, h plus 6 over h plus 6. And now we see, oh look, there's an h plus 6 on top here. There's an h plus 6 on bottom here. I get to cancel those out, and I'm left with just h plus 3 is my answer. All right, so this is the first way. But unfortunately, this way will not work all the time. As we saw back in the other ones, when we factor it, sometimes this is not going to be perfect. Sometimes they may not cancel anything out, and we would think, well, there's nothing we can do. There actually is. We'll get to that in 1 second. I want to see if you guys could do a couple more of these types on your own, just to kind of refresh what we did previously in this lesson. So I'm going to put a couple of problems up here. So I want you to do this problem here, b squared minus 2b minus 15 divided by b plus 3. I want you to try that one. And then I want you to try this one here. X squared plus 11x plus 24 divided by x plus 8. All right, so take about 5 minutes, pause the video here, and try and do these on your own. All right, remember, because we're dividing by a binomial or a polynomial, we're not going to just take each term and divide it by this. We're going to have to factor the trinomial, and then we can cross-cancel, or we can cancel out things that are the same on top and on bottom. So go ahead, give this a try. Okay, so hopefully these are the answers that we got here. For the first one, again, we rewrite it as a fraction. Then we realize that the denominator is not a monomial, so we have to factor the top. Two numbers that multiply to get negative 15 and add to get negative 2 are positive 3 and negative 5. Positive 3 times negative 5 is negative 15. Positive 3 plus negative 5 is negative 2. Now we see that we have a b plus 3 on top and on bottom, so those will get canceled out. And once they get canceled out, the only thing that I'm left with is a b minus 5 on top, so that would be my answer. Now for the second one here, same thing. Take the first part, put it on top. Take the second part, put it on bottom. Because we're dividing by a binomial or a polynomial, we can't just take each number up here and divide it by this. We have to factor the top. Two numbers that multiply to get 24 and add to get 11 are positive 8 and positive 3. So the top part will factor out to be x plus 8, x plus 3. I see an x plus 8 on top. I see an x plus 8 on bottom. Those are going to cancel out. And again, I'm left with just the x plus 3. Okay, so like I said, not all problems can be done in that manner that we just did. So, for example, let's say I had a problem like this. Y squared plus 4y plus 12 divided by y plus 3. Okay, now let's say we try doing this the normal way. We rewrite it as a fraction, the y squared plus 4y plus 12, and we divide it by y plus 3. And then I say, all right, what two numbers will multiply to get 12 and add to get 4? And, well, I realize that there aren't any. I can't factor that top one, right? Because the only numbers that multiply to get 12 will be 1 and 12, 2 and 6, or 3 and 4. And none of them are going to add to be 4, so that top trinomial is a prime trinomial there. But unfortunately, I can't just leave it like this. I can't say, well, I'm done. That's my answer. So we do have another way to divide our polynomials. And it's called long division. Now, hopefully you guys remember, probably from back in elementary school, how to do long division. So I'm just going to bring up a real quick one here. Let's say I wanted to divide... I wanted to do 15 divided by, we'll go with 6. Okay? So if we remember, the way that we learned long division was we said, how many times does 6 go into 1? Well, 6 doesn't go into 1. So then we said, okay, how many times does 6 go into 15? Well, 6 goes into 15 2 times. So we put the 2 up top. Then we said, okay, 2 times 6 is 12. And then we subtracted those two numbers. And 15 minus 12, that's going to give us 3. And then if there was a number here, we would drop that number down. But in this case, there is no number. So then we would just say, okay, how many times does 6 go into 3? It doesn't. And I'm talking about like back in like real elementary school, before you knew that you could put decimals in this, we would put remainder 3, right? So 15 divided by 6 would be 2 remainder 3. I want you to keep this in mind because this is how we're going to do this problem. So we're going to take the same exact approach as we just did with that long division problem. I'm going to take this first term, and that goes underneath the division. Y squared plus 4y plus 12. The y plus 3 goes on the outside. Okay. So then I want to say to myself, all right, y times what is going to give me y squared? If you want to think of it this way, it's a little bit easier to kind of think of. You could do y squared divided by y. You could take this term here, this first term, and divide it by this first term. So y squared divided by y. What is y squared divided by y? Well, that's just going to be y. So what I do is up top, I'm going to put a y. Just like we did in the long division, right? We said, well, y times y is y squared. 6 times 2 was that 12 that we had. So now I'm going to take what that was, this y, and I'm going to multiply it times the entire binomial here. Not just the y. I'm taking the y and multiplying it by y. And I'm going to take the y and multiply it by 3. So y times y is y squared. I have a plus, so I put the plus. Y times 3 is 3y. Again, if I go back to my long division problem, what did we do after we multiplied the 2 times the 6? We put it here and we subtracted them. So what am I going to do here? I'm going to subtract these two terms. Y squared minus y squared. You should realize that this first part here should always cancel out. So y squared minus y squared, that's nothing. 4y minus 3y, that's going to give me a y. Then, just like I said over here, if there was a term, I would drop it down. Well, I have a term here, so I'm going to take this 12, or plus 12, and I'm just going to drop it down. And now I'm going to do the exact same thing over. I'm going to say, okay, first term here, first term here. Y, how many times, or y times what will give me y? Or, like I said before, I could take these two terms and divide them. Y divided by y, that's 1. So up top, I'm going to put 1. Now, because it's a positive 1, I should put plus 1. If it was a negative 1, I would put minus 1. And now I'm going to go through the process again. I'm going to take this 1. I'm going to multiply it by everything in front. 1 times y is y. 1 times 3 is 3. And I am going to subtract these two terms. Y minus y, just like we saw up here, they cancel. They should always cancel. 12 minus 3, that's going to give us 9. So now here, there's nothing to drop down, right? Just like we had here, nothing to drop down. So normally we would say remainder 3, right? This is our remainder. Well, we don't just put remainders anymore. That's not something that we do anymore. What we're going to do is we're going to take our remainder, whatever this may be, we're going to put that on top, and we're going to take whatever's out front here, and we're going to put that on bottom. That is how you write a remainder when dividing a polynomial by a polynomial. This is how you write the remainder. You put the remainder on top, you put the number out front, or the polynomial out front, on bottom. And now, whatever you have on top, all of this on top, how do I make this? There we go. All of this on top, that's your answer. So my answer to this problem would be y plus 1 plus 9 over y plus 3. This would be the final answer. All right, so let's do one more together because I know that that may have been a lot for you. So let's do this one here. We have 3x squared plus 9x minus 5 divided by x plus 5. Okay. Now, in this problem here, we could try to do this in the factoring way, but we realized that the 3x squared plus 9x minus 5, that's not the easiest trinomial to factor, right? Especially because we have a coefficient here. So it does make this a little harder to even try to factor, which it may not even factor. You have to understand that either of these two methods are okay. The long division method works every single time. The factoring method only works if it can be factored and if the top and bottom have a common factor. So if you want, you can always start by doing the long division, and that'll always get you the answer no matter what. It's a little bit longer, but essentially it's a foolproof method. Okay? So let's go with our long division for this one. So I'm going to take whatever's in front, and that's going to go underneath my division. So we have a 3x squared plus 9x minus 5, and on the outside we're going to put x plus 5. Okay. I'm going to take my first term and my first term, and I'm going to divide it. So it's 3x squared divided by x. 3x squared divided by x, that's going to get me 3x. So on top, I put a 3x. I'm now going to take that 3x, and I'm going to multiply it by everything here. 3x times x is 3x squared plus 3x times 5 is 15x. I am going to subtract these two terms. So 3x squared minus, I don't know where that came from. There we go. 3x squared minus 3x squared cancels out like it should. 9x minus 15x, 9 minus 15, that's going to give me a negative 6x. Now, I take whatever the extra term is, or the next term, and I drop it down. And then I do the process all over. I take the first term here and the first term here, and I divide them. Negative 6x divided by x. What does that give me? Negative 6. So up top, I put a negative 6. I now take the negative 6, and I multiply it by everything in front. Negative 6 times x is a negative 6x. Negative 6 times 5 is a negative 30. Be very careful here. I am going to subtract them. You see how I'm always putting my minus sign a little bit off to the side here? I don't want you to get confused with this minus and this minus here. This minus makes this term negative. This minus is what I'm doing to the two terms. Okay? So you have to be very careful here, because negative 6x minus negative 6x, the minus negative becomes a plus, and you have negative 6x plus 6x. That does cancel out. But if you forget about that negative there, and you do negative 6x minus 6x, that's going to give you negative 12x. And then you're going to be a little bit frustrated because I said, and this is always true, your first two terms should cancel. There should never be a term here. Okay, and this goes the same for the next one. Negative 5 minus negative 30 minus negative becomes plus, and it's negative 5 plus 30, which gives me 25, a positive 25. If you don't have this negative here, you're going to do negative 5 minus 30, and that's going to give you negative 35, and you're going to get your remainder wrong. So pay attention to this minus. It's this term minus this term. Okay? But I do get a remainder of 25. I can't bring another term down. I can't divide these. So I'm going to take this 25, and because it's positive, I'm going to put plus 25 over x plus 5. So my final answer for this is going to be 3x minus 6 plus 25 over x plus 5. That would be the final answer. All right, so I've put one problem here up on the board. I do want you to try this on your own. Take 5 minutes, pause the video, do this one. Again, remember, you're looking at that first term. You're going to divide them. Whatever you get, that goes on top, and then you go through the process of long division. Multiply it by everything in front, subtract, bring down, repeat. All right, so hopefully this is what we got here. When dividing, we're taking this first term, n squared divided by n, you get n, that goes up top. Take the n, multiply it by n minus 2, you get n squared minus 2n. Subtract everything, n squared minus n squared cancels. 6n minus negative 2n, that's going to give us a positive 8n. Remember, minus negative becomes plus. Drop down the 2. Now I have an 8n plus 2. I repeat the process. 8n divided by n. That gives us an 8. So the 8 goes up top. Multiply the 8 by the whole front. 8 times n is 8n. 8 times negative 2 is negative 16. I subtract them. 8n minus 8n cancels out. 2 minus negative 16 becomes plus. That becomes an 18. This is our remainder. That goes up top. The n minus 2 is on bottom. So my final answer should be n plus 8 plus 18 over n minus 2. Okay, so one more thing. Still working with long division. Let's say we had a problem like c to the third plus 5c minus 6 divided by c minus 1. So you would think that this is no different than any other problem. This is very, straightforward. We want to put this in our long division and do everything that we did before. But there is one problem here. And that is this to the third power. When we do long division, we have to have every power accounted for. Meaning, if my first term is c to the third, I need to have a c squared, a c, and no c. If my first term was a c to the seventh, I would need a c to the sixth, to the fifth, to the fourth, to the third, squared, c, and nothing. Every single power has to be accounted for in every single long division problem. So if you are missing a power, you have to put it in there. But remember, we can't just add in numbers without changing the value. So how would we add in a c squared without changing the value of this term? Well, all you do is you put a 0 in front of it. Because a 0 c squared is actually just 0. Because 0 times anything is 0. So really, all I'm doing is I am just changing the way that this first term looks. So before I put this into long division, I have to say, all right, I have a third power, but I don't have a second power. So let me rewrite this. It's going to be c to the third plus 0 c squared plus 5c minus 6 divided by c minus 1. Now I have every exponent accounted for. 3, 2, 1, no c. Now I can put this into long division and look to divide this. But nothing changes. Even though we have a little bit more terms than the previous ones we were doing, everything stays the same. You're just going to have to maybe do this one more time. So I take the first terms, divide them. C to the third divided by c, that's a c squared. Multiply. So c times c squared, that's c to the third, minus c squared times 1 is c squared. I subtract. C to the third minus c to the third, nothing. 0 c squared minus negative c squared. Remember, this is a coefficient of 1. So we're really saying 0 minus negative 1. That's going to be a positive 1 c squared. I bring my next term down. Only the next term. Don't bring them all down. I mean, even if you bring them all down, it's really not a big deal, but only bring the next one down. It makes it easier. And then I do the same thing. Take the first terms, divide them. C squared divided by c, that's a c. Positive c. Multiply. C times c, c squared. C times 1, negative 1c, subtract them. Subtract those, they cancel. 5c minus negative 1c, that's going to be a positive 6c. Bring down the minus 6. I have another term, so I have to do this again. You've got to do it until every single term gets used. So the longer this is, the longer your polynomial underneath the division bar is, the longer you're going to have to do it. But again, it shouldn't be too much of an issue here. But I then divide that, I bring that down, and I say, okay, do the same thing. 6c divided by c, that's going to be 6. Put the 6 up top. Multiply. 6 times c is 6c. 6 times negative 1 is negative 6. I subtract them. And here, 6c minus 6c, that's 0. Negative 6 minus negative 6. Oh, wait, that's 0 too. So I don't have a remainder. We haven't talked about that. What happens when you don't have a remainder? Nothing. You don't put a remainder. You don't put plus anything here. If you don't have a remainder, that means that this is your final answer. C squared plus c plus 6. That would be it. Okay, so you do have to make sure that you put in, this is what we call a placeholder. You have to have every single exponent from your highest down to your lowest. Okay, make sure you do that first. That's got to be the first thing you check when doing long division.